So this is our last unit we're getting into. Instead of lines, linear graphs, which are lines, linear line, we're going to look at what are called quadratic graphs. These are what they look like. And I want us to just notice some things about both of these. This one is somebody kicking a soccer ball. Do you all have an imagination? Can you imagine someone kicking a soccer ball? Good. This is someone doing a high dive. They're on the diving board, they dive, and then they come down here into the water. Okay. So I want us to notice three things about these graphs. The first thing is where they start. Where does the soccer ball start? Which means it's on the ground. Okay, so starts on the ground, which good, that's the origin. And the reason it's 0, 0 is because no time has gone by. It starts at time nothing. Now, the high diver guy off the diving board does not start on the ground. He starts how many feet up in the air? 24 feet up. That's what's called an initial position. Initial means starting. Are you with me there? Initial position. Okay. A lot of you will go on to take physics later on in high school, and you'll talk about like initial velocity and stuff like that. So initial just means starting. So where it starts is important. The next important point I want to look at is called the vertex. Have you heard that word before? Or do you know what vertex means? Or like, it's the center, like the high point. So how far up in the air does the soccer ball go? Well, you'd have to count those little boxes. So 1, 2, 3. I got 18. Okay. So the maximum is 18 feet for the soccer ball. This one will be a little easier because it's labeled. What's the maximum height of the guy going off the diving board? Good. The max is 27 feet. Good job, George. So the starting point is important. The vertex is important. And the other really important point is where they end. So how long, and I mean, how many seconds does it take the soccer ball to come back to the ground? Okay, lands after 1.5 seconds. And the guy on the high dive lands in the water after how many seconds? 4 seconds. Good. Do you see that there? So lands, or I guess splashes, after 4 seconds. So that's like being able to read a graph. And the three important points are where it starts, where it ends, and then the vertex point. So do you remember lines? And it was y equals mx plus b. Go ahead and close that. Do you remember y equals mx plus b? Yes. Can you close that? I know he's not here. And can you close that? Thank you. Can you close that? Thank you. Remember y equals mx plus b for lines? This time for quadratic, it's y equals ax squared plus bx plus c. Do you remember your trinomials where we did the x box? Where you had an x squared and then an x and then a number. That's the pattern, but we call it a, b, and c. Ax squared plus bx plus c. So how are quadratics different from linear functions? Well, it's not a line. Instead, it's this U-shaped graph, which we call a parabola. P-A-R-A-B-O-L-A. P-A-R-A-B-O-L-A. Parabola. Sounds like a disease. Parabola. It means that instead of a line, it's shaped like a U. Coming with me on that? And usually the word problems are about things that go up and come back down. Like it's literally rocket science. You know what I'm saying? Rockets that go up and come back down. So you're all rocket scientists now. That's what parabolas are. It's a curve. Instead of a straight line, it's a U shape. Now, they can either open upwards like a smiley face or downwards like a frowny face. And it's based on that A value. The A value is the one with the x squared because these can be like jumbled around in some other order. If A is positive, it opens up. If it's negative, it opens down. Does that make sense? Positive up, negative down. Coming with me on that? Good. Heads nodding. All right. So when you look at this one, here's your x squared. What is in front of the x squared? I realize it's nothing. A one. Good. It is a 1, specifically a positive 1. And so this would open upwards. If A is positive, it's going to open up. It's a little weird because it's not written. Now, again, the terms can be all jumbled up. You have to look at the x squared. So watch where I'm pointing here. Do you see how it's a negative x squared? So it would open down, and that a value is a -1. So you always look at the x squared for whether it opens up or down. Positive up, negative down. Smiley face, frowny face. Not that complicated. And plus, you're going to rely heavily on the calculator for a lot of those. Now, these ones, you're given the graph, and we're just going to answer all this information about it. This is really simple and easy. So I'm betting what's going to happen is you're going to stop listening to me because you're going to be like, oh, we understand this. Please don't do that. Please keep listening to me because you don't want to miss the easy questions. So look at this one. Is it opening upwards or downwards? Up. Very good. The vertex, and I'm pointing to it, it's this point right here, the center. You have to write it as a coordinate, something, comma, something. So it would be 2, comma, -1. Oops. 2, comma, -1. I don't actually know the origins behind the word vertex. Oh, well, it's vertex, V-E-R-T-E-X. You'd have to Google that one. I don't know the answer to that. All right, your y-intercept, and again, I'm going to point to it. It's this point right here. It's 0, comma 3. Good. In your check your understanding on delta math, they're going to ask you for x and y intercepts, and you have to put that 0 in there. Do you understand? You have to put the 0 in there. X intercepts. Now there's 2 of them. It really doesn't matter what order we write these in. What's the first one? 1, comma 0. Good. And then the other one, 3, comma 0. Now, domain and range. That's always a difficult topic. Domain is left to right. Domain is left to right. Domain is left to right. Left to right. It's all your x values. So look, I know there's not arrows on the end. You can put arrows on the end. Do you see how this is going to go left forever and right forever? You get everything. I'm going to write it and see if you guys remember this from a long time ago, but do you remember X and then that little E thing, and the R stands for reals? It means all real numbers. And I said, that's a really common answer. It shows up a lot. It means everything. We did it back in unit 2. So I know that was a while ago, but that means everything, left and right forever. The range is not going to be everything. And you have to watch me point to this. Do you see how we start here? And we want everything above here. In fact, let me draw a line on there. We're starting here and we want everything above. So what number do we want to stay above? -1. Y is greater than or equal to, good, -1. Good, you guys got that. We want to stay above -1. We're just going to try all that again with this graph. Same concepts, just different numbers in it. Now, does this one open upwards or downwards? Down. Good. It's not difficult. And see, this is where I'm scared you're going to stop listening to me because you're going to be like, well, this is really easy. I can tune her out. Don't do that. You don't want to miss the easy one. All right, your vertex is this point here. 1, comma 4. Good. Your y-intercept, and I'm just going to point to it. It's this point right here. 0, comma 3. X-intercepts, there are 2 of them. -1, comma 0 and 3, comma 0. Domain, again, you can put arrows on the ends of that if you want. It's going to go left and right forever. So we say all reals. That's how you say that. The R stands for real numbers. It's all real. It just means everything. And that'll be the domain. Like, that's the answer for the domain. So the range, now I'm going to draw this pink line on here. We need to now stay below what number? 4. So we're going to say y is less than or equal to 4. Good job. You did. Very good job. Stop arguing. You all did a good job. All right, so now we're going to sketch the graphs for these ones with the following characteristics. Just watch, and I'll give you, you don't have to rush to catch up. It's recorded, okay? Just pick up where we are. So we're going to put these x-intercepts and make it open upwards. So 0, 0 would be right here. That's the origin. So put that point. 4, 0 would be right here. And what you want to do is draw a U shape, a parabola, that opens upwards and goes through those 2 points. So as long as you connect to those 2 points and make it face upward, that's it. That's what the question's asking. That was super difficult, right?
Yeah.
So for this one, we're going to plot these 2 points. So -3, 0 would be right there. And then 1, 0 would be right there. And all you have to do is draw a U shape through those 2 points that opens down. So something like this. Again, I'm not here to grade your art skills. Just go through those 2 points, make it a U shape facing the correct direction. Now, everyone that we've looked at so far has 2 x-intercepts. It's possible to just have 1 x-intercept. So watch how this would look. You would plot the point 1, 0, which is right there. We want to make it open downwards, but not go through the x-axis at any other points. So it would look like this. Are you following me there? See what I'm saying? Like it'll just hit at that 1 point. So it's possible to just have 1 x-intercept. So, hey guys, this is what it looks like if there's 2. This is what it looks like if there's 1. Could you ever have 3?
Yeah.
For a U shape.
Yeah, not for
For a U shape, you could not get 3. You could have 2, you could have 1, or you could actually have 0. Like, so we're going to draw 2 different quadratic graphs. That's a parabola, U shape, with no x-intercepts. So you can make it face upwards and not touch the x-axis at all. Or you could make it face downwards and not touch the x-axis at all. So the big takeaway there is you can have 2, you can have 1, or you can have none. Those are the options. Okay. So we will do our 3-minute break here. All right. So next thing is a little bit of vocabulary. And I'm sorry, let me shine this up here. So x-intercepts are where the graph touches the x-axis. And that's what we were just looking at on the other side of the paper. So it's where the graph touches the x-axis. That's this one, like the horizon. So a few pieces of vocabulary about that. The x-intercepts are also called zeros. And that's because when they touch the axis, it's something comma 0. Okay, so we call them zeros. They're also called roots and solution. So that's a lot of words for one thing. X-intercepts, zeros, roots, solution. The directions could use any one of those. So you have to know that that's what they're asking about. Okay. Now, when you're finding these, and you're going to use the calculator a lot for this, and it's super helpful, it'll basically give you the answer. You have to make sure the function is set equal to 0. If it's not, that's the first thing you need to do is make it equal 0. If it doesn't equal 0, you're not going to find the zeros. That should make sense. Okay. Now, these ones, we're just going to look at the graph. So where is one of our x-intercepts? 3. Now, when we write it as what's called a 0, you can actually just write the number 3. Or you can write 3, 0, that's fine. But just 3 will do. If we're calling them roots, you can kind of get away with doing that. Good. And then the other one is 6. That's it. Just have to understand what the vocabulary is asking you. If it says find the zeros, you have to know that that's what it's asking for. How about this one? 1. No, I would mark that 100% correct.
Okay.
Now, these ones, you don't have a graph. Watch me do this. When you take this Unit 10 test, this is about half the test. Are you ready? Do you see how this already equals 0? That means I'm good. I'm just going to go to my calculator. Oh, let me share my screen so it'll show up on the recording. Go to my calculator and I'm going to type in. Just watch this, please. X squared minus 7x plus 6. You don't type the equals 0 part. Okay, just type that. Look at this. I click on that one. What's the answer? 1. Watch. I'm going to click on this one. What's the answer? 6. Those are the answers. That's about half this test. is what are the zeros? Now this one, there's gonna be one extra step because do you see how it doesn't equal 0? You would have to add the 2 to the other side first to get it to equal 0. So you just have to be mindful of that, okay? So just watch out. Now you'd probably catch it because when you go to type it in the calculator, you're gonna be like, hey, wait, that's weird. But it would be 5x squared plus 11x plus 2 equals 0. And I'm gonna, again, share my screen, go to the calculator, and we'll type that in. Are you ready? Please don't miss this because, again, this, you just get your answer from the calculator. All right, what was it? 5x squared plus 11x plus 2. Watch, I'm just gonna click on them. What's the first one? -2. And then this one, -0.2. So we got -2 and -0.2. Yes, it can be decimal. Yeah, like it's just gonna tell you the answer. Whatever it is, that's what you get. Okay? Now we have to also, the last thing you have to be able to like make a connection with is between the zeros and what's called the factors. You have to remember that it's opposite. For example, give me a single digit number. 4. If the 0 is 4, the factor is x minus 4. And that's because 4 minus 4 is 0. Give me another single digit number. 3. Okay, for example, listen to me. If the 0 is -3, the factor will be x plus 3 because -3 plus 3 is 0. Okay, thank you for coming with me on that. So this says write the equation. So I need a y equals. If one of your zeros or solutions, they're calling them this time, you have to know that that means the same thing. If it's 1, your factor is x minus 1. Again, because 1 minus 1 is 0. And then for 6, it'll be x minus 6. Doesn't that look like exactly what we just did on the last test with factoring? That's why they're called factors. And that's crazy, right? Now let's do this one. Y equals. For 0, you can write in parentheses x minus 0 if you want to, but hey guys, what is x minus nothing? X. So I would just put x. If you put x minus 0, I'll mark that correct, but x minus 0 is just x. Oh, good. And then for the -2, we'll have x plus 2. If it really bothers you that this one doesn't have parentheses, you can certainly give it a hug as well. Now I wanted us to go back and do the same thing for examples 1 and 2. So come back up here for 1, put y equals. Now one of our zeros was 3. So what's the factor going to be? Yeah, x minus 3.
So we basically just do like the opposite.
Yeah, it's just the opposite of what's there. So what would the other one be? This is 6, x minus 6. Good. This last one's a little tricky. I like this though. You're going to put y equals. Now your 0 is at 1. Do you see how there's only one of them? It would be x minus 1 squared. Whenever there's only one, that's a twin. But without the squared, it would be a line instead of a U shape. So you have to have the squared in there. But when there's only one of them, it's a twin. So it'd be x minus 1 squared. And then go and flip to the back. We're just going to wrap it up with the same way we started, which is looking at a story problem and kind of interpreting the graph here. So this is about you guys are rocket scientists. Rocket science. A rocket goes up, comes back down. Everything is nicely labeled for you. I'm going to zoom out here so that we can see the whole thing. Okay, so it says, what is the initial height? What does that word initial mean? Initial means starting, 108 feet. 108 feet, that's this one right here. What is the maximum height? So you're looking at the vertex. How far up in the air did it go? 144 feet. Just that point right there. The next question is a time question. When does the rocket reach the maximum height? Watch me points to this. 144 is the maximum, but the time it happened at 1.5 seconds. Good. And then the last one is also a when question, so it's time. When does the rocket hit the ground? 4.5 seconds.